a really big question from the concept of functions, derivatives, integrals, and you can say your basic logical structural reasoning. If you read this question, it will take you some time. I will allow you a little bit of time so that you can refer back to this video later on and observe the question over and over again. But I will suggest you pause the video and note this question down or find it from somewhere and then go ahead for solving. There is a function, a cubic function if you observe. And the domain is from 0 to 1, the range is from 0 to 1. So, it's a 0 to 1, 0 to 1, it's a square region in which this function is to be considered. Now, in the square region, there is a green region defined such that the y value is greater than the fx. And there is a red region that has been defined such that y is less than fx. That means, if I take the curve of the function like this, the part of the area in this square region above the curve will be green and part of the region below the curve will be red. Now see, this line LH which is defined with a h value which has not been specified, but for all x values from 0 till 1 over the entire domain, this h can be fixed up depending on wherever you choose the h value. It can be taken as, for example, h equal to 0.2. That means a horizontal line y equal to 0.2 would be defined as LH. And now you are asked several questions. We will go to these questions a little later. Before then, we will just explore this entire functional structure. How does its graph look like and where does it exist? So let us go ahead and we will draw the graph based on the derivative analysis of this particular description given. Right at the beginning, this is a cubic and leading coefficient is positive. So that means this function is cubically going to rise like this, then it might bend below and then again rise. Leading coefficient is positive. So what I do is I calculate f dash of x. It's going to be x square, 3x square, 3 cancels, and minus 2x plus 5 by 9. And this is derivative 0. So that means this is going to be x square minus 2x plus 1 plus 5 by 9 minus 1. So effectively this brings us x minus 1 whole square and 5 minus 9 means minus 4 by 9. So effective this is x minus 1 whole square minus 2 by 3 whole square. This is going to produce x minus 1 minus 2 by 3. So that is going to be minus 5 by 3 and x minus 1 plus 2 by 3. So it's going to be minus 1 by 3. I hope I'm not wrong. Minus 1 plus 2 by 3. So minus 3 plus 2 minus 1 by 3. And this is your f dash of x. So that means if we take a graphical plot like this, with x varying from 0 till 1 as stated as the domain and y values varying from 0 till 1 again, then we have a square region as defined in the question, and this is that square region, and this is where the entire functional plot is to be considered. Now f dash is going to be equal to 0 at f dash x equal to 0 means it can happen at either 1 by 3 or at 5 by 3. There are only two positions. So let's consider this as a 1 by 3 position, this as a 2 by 3, and let's go a little ahead and let's say this is some 5 by 3 position on the x-axis. So what is going to happen is, let us squeeze this region a little. Let's say we make this x equal to 1 lie over here so that this x-axis has a 5 by 3 over here, let's say, and this is the square region. All right, so do we need to make some shifts here? Or maybe possibly. Just a moment, and let's say this is your 1 by 3 and this is some 2 by 3, and that's 1. Okay, we are ready to go. Now see, your slope is 0, but you do not know whether the function will have a valley here, or a mount here, trough here, or you can say I mean a minima here or a maxima here. You do not know. If you consider leading coefficient to be positive, then this is surely going to have a follow like this. It will rise, go through a zero slope, get down, and then again it will rise. But here is a specific question: where is it going to change its curvature from a maxima type to a minima type? This is the question. To answer that, what I can do is I can calculate f double dash of x and then equate it to 0. F double dash of x equal to 0 is a point of inflection. Now, f double dash of x equals to how much? Derivative of this would be 2x minus 2, and that would be 2 times x minus 1. So in case f double dash of x is equated to 0, that means if its rate of change of f dash x is to be considered 0, then that will happen at x equal to 1. Now at x equal to 1, this is the position where its curvature would change. So finally, the graph should go like this. And now if I consider at 0, f of 0 will be equal to how much? F of 0 will be equal to 17 by 36. So f of 0 is another thing that we need. It's 17 by 36, means very close to 0.5. 18 by 36 is 0.5. So let's say this is some 17 by 36 position. From here till here, this particular value is going to rise. From this point, it's going to rise. Now, what is f of 1 by 3? F of 1 by 3 is going to be 1 by 3 power 4, that is 1 by 81, minus 1 by 9, plus 5 by 27, and plus 17 by 36. And now if I take 81 as a common denominator over here, so 1 minus 9 plus 15, 1 minus 9 plus 15 plus 17 by 36. So f of 1 by 3 is going to be equal to 81, means 16 minus 9 is a 7, 7 by 81 plus 17 by 36. So that makes it 9 into 9, 9 into 4. So let's call this 9 into 9 into 4. So this is going to be 28, and plus 36 means 17 into 9 is 153. 9 7s are 63, and 9 1s are 9, 153. So effectively that makes how much? 153 plus 8 is 161. 161, 181 by you can say 81 into 4. So 81 into 4 is 4 1 4, 324, 324. So this is going to be the f of 1 by 3 value. And what is the value at f of 1? Now let's consider again. 1 by 3 minus 1 plus 5 by 9 plus 17 by 36. So effectively, if I take the total common denominator as 36, this is 12. 12 minus 36 minus 24 minus 24 plus 20 minus 4 minus 4 minus 4 plus 17 is going to be 13. So it's going to be 13 by 36. Your f of 1 value is going to be 13 by 36. That means this is far less than 0.5. 18 by 36 is 0.5. So therefore, I am here, let's say I am here at x equal to 1. This is 13 by 36. This is the level of 13 by 36. This, and this is 17 by 36 level. So what if I have to draw the graph? The graph would have a zero slope at 1 by 3 and at 5 by 3. So if the graph is a zero slope at 1 by 3, then this is of f of 1 by 3 means 181 by 324. Again, I will say 324 means 162. So this is a little more than 0.5, but let's consider this as the position. This is the height of 181 by 324. Let this be the graph. Now this graph is going to decline and pass through this, and then it will pass through this. This is the valley point at 5 by 3, and approximately this is how the graph will look. So far what we have done is only considered the cubics graph. This was entirely important in this question, and I'm taking a long time, I understand that. This is going to take a little more time for the details that it involves. We have taken the derivative, first derivative, so the slope is considered, the curvature is considered, the second derivative tells us where the inflection is, and the function values at these two specific positions are taken. Now one more interesting fact you will see in this question is the amount of area that this curve covers above the x-axis between these two ordinates, that which you call in this question as the red region. Let's say this is 13 by 36. F of 1 is 13 by 36. I'll just write it here, 13 by 36. Now see, the red region that we consider here, how much is the magnitude of the area in this red region below the curve? How much is the magnitude? So by integration we shall get it direct. So area bounded, area of red, let's say the area of the red is equal to how much? That's going to be integral of 0 to 1 fx dx. So if I go straight, then x power 4 by 4 will produce x power 4 by 12. So that will be 1 by 12 minus x cube by 3. So 1 by 3. Lower limit being 0 need not be considered. Plus 5 by 9 x square by 2 means 5 by 18 plus 5 by 18 and plus 17 by 36 into x, that is going to be 1. So in all, if I take this as a 36, then I have how much? 3 times. So 3 times means 3. 3 minus 12 is minus 9. Minus 9 plus 10 is 1. 1 plus 17 is 18. Now you see the area of the red is exactly equal to half. This is the area of the red. This area is equal to half. Now if this area is equal to half, the amount of area that has been consumed by the green region, that is this region, the region above the curve, this region will also be exactly, this area will also be exactly equal to half. Now if I consider as per the question the options, you will be amazed at the simplicity of the solution that we can build from here on. Now you see, option A, that says that there exists an h. All the options, in fact all the 4 options, they ask you about an h value between 1 by 4 to 2 by 3. Let us locate it. Let us locate those positions. 1 by 4. So if this is close to 5, this is, let's say, 1 by 4. And if this is 1/3, this is 2/3. Now let's say this is the 2/3 position. That means this particular level is at a height of h equal to 2 by 3. And this particular height is at a position of h equal to 1 by 4. Now you are going to consider from here till here. If you say h is element of, if h is element of 1 by 4 comma 2 by 3, our consideration for the line LH will be these horizontal lines. And now if I go for option A, it says that there exists an area of green region above the line LH, which equals the area of the green region below the line LH. Here is the problem. If this is where LH is at the maximum level, for the green region, this has already consumed 1/3 of the height. This is already 1/3 of the height and 1 unit width. Therefore, this area is equal to 1/3. This area is equal to 1/3. And this total area is equal to half. Now that means from 50%, 33% is being consumed here. 17% is what lies below this line and above the curve. And this LH line is going to come slowly below. If it comes below, the area above is going to increase. No way can we have a position of LH going below such that the area of the green region above becomes equal to below. Why? This is already 33% and this is 17%. This is 17%. This green region is 17% close to. And you are reducing that, so equality is never going to happen. Option A cannot happen. Clear cut. Option A is wrong. Cannot happen. Option B says that area of the red region above the line LH equals the area of the red region below the line LH. Now let's come to the red region. The area of the red above the line equals area of the red below the line. Now if I take a line here, this is 1/4 position, and you see this is a greater area and this is a lesser area considered, and this total area is already half. So there is a big possibility that there can be a certain line such that the amount of area below and the amount of area above is obtainable. Why so? Let me clarify this. Now you see, this is 1/4. This height is 1/4, right? And this width is 1. So this much area below is already 1/4. How much is left above is area of equal to 1/4. The red region above and the amount of red region below. That means this is the line LH that is considered in the option B. And option B says that the amount of the area of the red region above the line equals the area of the red region below the line. This is that line. Y equal to 1/4, and option B can be accepted as correct. And option C says that the area of the green region above the line LH equals the area of the red region below the line LH. There is a possibility. Let's say if I take such a line here. Now amount of green region above is equal to the amount of red region below. If I am going wrong, let me read it again. Area of the green region above the line equals area of the red region below the line. That means if we consider such a line, then amount of the green region above, area of the green region above the line equals area of the red region below the line is very much arbitrarily findable. It is possible that it is obtainable. So if I take a scratch line like this, let's say amount of the area of the green region above equals area of the red region below. Some sacrifice of the red here and some sacrifice of the green here can be equated. And therefore, option C, yes, is possible. It is correct. And finally, option D says that the area of the red region above the line equals area of the green region below the line. Now that's amazing. Say this, area of the, just a moment, area of the red region above, area of the red region above this line, above the line equals the area of the green region below the line. Now area of the green region below, now this is the green region below, this is the green region. Now see, this area and this area, they can be equal. Area of the red above equals area of the green below. This is quite possible, and therefore option D is also correct. In an advanced exam, you need to consume far less time than whatever we have considered or consumed in this discussion. I have elaborated this discussion so as to make you understand the requirements of the question. I will always say that you should be a bit more speedier and less work oriented, more concept oriented, and your mental working should be a little more. This is all about this question. Then options B, C and D stand correct. It gives me enormous pleasure, let me tell you this, and it gives me enormous amount of happiness to share with you the discussion of this question. This is a question which belongs to high strata of ranks. If you can solve this well within time, your rank is going to definitely be much better than who are not being able to do this question. This requires your understanding of graphs, curvatures, derivatives, integrals, and the idea about the dynamic change of areas. These are new types of questions. I hope you will follow this discussion as many times as needed without hesitation, and you will try to solve this question on your copy by yourself. Always go for self-working mode after you have learned something. All the best and stay subscribed. Thank you for your patience.